All right, hi everyone, my name is Jonathan, and today I'm going to talk about Coherent UX and accessibility, reinventing the cultural heritage framework for Convergent multimodal editions. So basically what I'm going to talk about is a piece of software that we've been developing at my department, and using it in some of our projects, but some of it didn't work well. We knew we needed to rewrite this, and I'm going to walk you through the process of that rewrite, in the hopes of it being beneficial for you all. First off, however, a bit of background about myself. I'm a research software engineer at a German Academy of Science. These academies execute humanities and social sciences projects, and usually these projects have very long funding periods of 12 or more years, which leads, of course, to the requirement of the software that we use to be very adaptable. So, for example, if we have an object repository or image repository, they might decide after some time that they need a dictionary component, because that's just how these kinds of projects work. We have a lot of editions under our umbrella. That can be letter editions, music editions, or any other sort of edition. And also more vaguely cultural heritage projects that can be material or immaterial cultural heritage. The websites we produce are in theory obliged to be privacy preserving and accessible. In actual fact, of course, as with other editions, accessibility leaves a lot to be desired. There was a particular focus in this rewrite to take this into account and get this right. The academy in Mainz that I work for also coordinates NFTI for Culture, which is a German research infrastructure provider. I'll say a few more things about that later. The title says Multimodal Cultural Heritage Edition. What does that mean? That can include, as I've mentioned, dictionaries, letters, but also essays. It can include object repositories, images, but also 3D data, or music, other immaterial cultural heritage, and a lot of different types of data, possibly. All of those usually have some notion of people, locations, and events, so these are basic data types that we have across the board. All of these records need at some point to be created, they need to be managed, they need to be published, and right now, or before that rewrite, we often had very complex technical setups with pipelines getting data from A to B and piping it through a lot of different routines that were hard to also be knowledgeable about and find issues, for example. With the software stack we've been using, like we have a Typo 3 based solution, that's a content management system. We've experienced a number of different issues that I'm sure many of you have encountered as well. So we were looking for a good methodology to approach this rewrite. What we, of course, did first is to look at what's in the market. Are there any projects that we can just contribute to and then benefit from all the greatness that everyone else has been working on? So we have, as I mentioned, a Typo 3 based solution. It's a concept from 2017 by my colleague and boss Thorsten Schrader. The issue of which usually was we never had enough time to test everything, to release everything, get everything in a state where we would want to offer it to someone else. Only for individual components we manage this. There are other solutions like Kitodo, also Typo 3 based, or Whiskey, a form builder based on Drupal. Some of our projects also use Wikibase Suite, which is neat, but also not necessarily particularly nice for managing a large number of records, and provides, of course, as every solution, limitations of what you can do with the data. Projects under our umbrella have also looked at tools like Lexonomy, if they were focusing on lexicography, or object management software like Omeka, Arches, Collective Access. We also use a lot of XML tools, including TI Publisher, Mermaid, Edirom, Ediarum, all of which are built around Exist, which is an XML database. But none of these really fit our needs in terms of projects that have changing requirements over a long period of time. So we then went a bit further and said, okay, we're gonna keep developing that cultural heritage framework, but we need a new approach to this. And we found it in media ecology. So here's a brief info for you. Media ecology tries to find out what roles media force us to play, how media structure what we are seeing or thinking, and why media make us feel and act as we do. Ecology is the scientific study on organisms and their interactions with the environment. In this context, an ecological approach focuses on the distributions, abundances, and relations between organic and non-organic beings in an ecosystem. So what it basically does is it understands software also, like other media, as part of one ecosystem or possibly several ecosystems. And that thought really helped us get our requirements list right. So that's something I can only recommend to everyone else. What has that done? In very basic terms, we've had user stories before, but now we focused, for example, on the desires of the communities we cater towards. We have a number of these little shifts that have happened with this changed perspective. We're looking, for example, more at generic models instead of trying to map a very, very, very niche and particular domain. We look at existing ontologies and what we can learn from them. We don't just look at how can we produce a component that's reusable, but also possibly are there any components that we can just remove and add a little functionality to another component, and then it's a more lean software that we have an easier time maintaining afterwards. In terms of how we model our data, how we write our software, that approach also shifts us more towards looking at resilient technology, as in battle-proven, and looking at how data can easily flow from one place to another where it's needed, and still be open to how these things may change over a long span of time. So what I'm going to show you is more or less the result of this analysis. Ecosystems here, of course, means different environments that the software needs to function well in. And what you can see here is the login screen. So one example of these ecosystems, editors working on the data need to have a neat interface to work with, where they can easily get their job done without it being much of a hassle. So this is what we came up with, what I came up with, a set of different ecosystems. I'm not going to go into all of them, but you can see up there environmental concerns did play a big role. How can we simplify things to make them easier, less energy consuming? We found accessibility to be an important aspect for this project because this is something what we've produced has been lacking sometimes, and where we wanted to do better to provide equitable access to what we produce. We also looked at various kinds of infrastructures, as in APIs that people ask us to provide to access the data in order to feed, for example, a federated content search in one domain or a knowledge graph in another domain. We also took into account German academia. This might sound strange, but whatever we do, unfortunately, it also means it needs to be maintainable for newbies. So simple code beats elegant code in this kind of project, because, as I said, German academia can be harsh. And we also wanted to make sure that we play well with bad faith actors. We are aware and have this on our servers as well. For example, AI bots that have run wild and just keep the server volume very, very high without doing a lot of things with the data. So we also looked at how can we improve the situation, for example, by offering a bundle to just download. And with that, we have an easier time of just saying, well, you don't stick to the rules, you're not welcome on our server. If you stick to the rules, you're good to go. Here's a bundle of all the data you need, just download it, go. To break it down a bit more, I wanted to present basically a chain of some of these decisions. So the analysis of digital ecosystems then very quickly led to the idea what we're going to need is still going to be like a conservative technology, a relational database, but be enabled for web apps and also to produce graph data, because that's also what we work with and what we want to do with our data. It needs to be multilingual. It needs to be accessibility enabled. So even if it has some sort of configuration interface, that needs to be accessible. We want to use a specific set of server-side languages that's mostly PHP, but we also are okay with using Python, especially for RDF stuff, and Rust, because we know a nice search engine that's written in Rust. One coherent semantic data model is what it says here, and that's probably the most controversial decision that I took. The idea is that to some degree one size is going to fit all, because if the project is looking at objects, be they stained glass or inscriptions or whatever, they're going to have the same needs. And of course the challenge then is to provide a good data model, and I hope we've managed to some degree. Then one decision that also came out of this was we're going to apply the rule of least power. Some web devs among you may still know this. It's an old idea, but it boils down to using as little JavaScript as possible, even if it's not on vogue, but producing everything in HTML and CSS as much as possible on the server, and have an atomic accessible CSS built around it. Then all pages should contain embedded metadata, so it can be easily harvested. And one thing that's still in progress that I'm working on right now is visualizations and different kinds of testing of the software and the front ends we produce. The overall goal, of course, is producing a semantic portal with equitable access for everyone. So the solution contains data models, editing interfaces, serializations like XML versions of the data, or linked open data. It contains UIs that are just ready to use, embedded metadata, a search provider, social connectors, and a container to run everything with on the server or locally. Each project can have its own specific overrides, but then of course it's also responsible with how that data is treated, how it's included in the various serializations, and so on and so forth. And then there are a couple of optional components. If you need to cater to specific APIs, we try to provide an extension for that, or quality assurance routines, or visualizations. You also don't have to work with this editing environment. You can also just ingest data. For example, we have a project that wants to keep working with Oxygen XML and the interface we've built around this. And that's also possible with that solution. What do these components look like? What you can see here is the basic data model. As I said, Typo 3 is a base layer. I'm going to try using my mouse here. Typo 3 is a base layer. It provides user management, content management, but also a nice model view controller framework that's neat to work with. It's not always easy, but it's neat. And one central extension that provides locations, dates, and actors that needs to be installed whenever you use the cultural heritage framework. It also contains the user interface library. You can use all these interfaces, but you can also, of course, override them with your own. And it produces, includes a number of other basic stuff. And then you can pick and mix, basically, what you need. There is a bibliography component with a Zotero import, for example, one for publications that can be more blog focused or like a retro digitization project as well. There's a lexicography component, a media component, a glossary component, and different kinds of maps. And in the second half of this year, I also want to work on a music and a letter component, because we have web pages using a lot of like an older tech stack, where this could come in handy also for our legacy portals. And then there are more generic extensions, like one providing a Sparkle endpoint, one providing quality assurance dashboards and visualizations, as I said. And there's a project extension that you can just, it's a boilerplate, you can adapt it to your own needs for a particular project. The basic setup is the same for each of these components. This might look odd, but what it contains is actually a number of main classes that you can, like, where most of the work is being done, and a couple of support classes that are reused everywhere. And then a flexible tagging system to provide structure, and a relation system in case you need to connect one of these main classes with another and qualify that relation. That's the overall idea, and at the top there's an abstract resource. What does that look like in reality? This might be very small for you guys, but you can see here there's an abstract resource here, and if you want to have an object resource, it basically just adds 3 additional fields to the model, and then you can manage all your object-based data. And there's a class called Abstract Heritage, which is inherited by, for example, the single object model. And most of the fields are just taken over from the original there. Last point on my list, coherence and accessibility. You can see on the right already what the interfaces this produces are able to be installed as web apps. So that's neat, even though they use a lot of conservative technology. They work well on mobile. And we've taken a number of decisions to make sure they also are nice mobile apps. There's a bit of animation here and there, and you're not fixed on having one particular layout. This is for the German Dictionary of Surnames, for example. Same here. But using the same software, you can just add a bit of CSS variables at the top, and then it can look like this. Which is the stained glass project that we have. So what does that mean, accessible web apps? Our focus really is here on making it accessible to everyone, both bots and humans. Server-side templating also includes bot access. This is something we've learned from that experience. We've had to build a custom-made CSS framework to work well with semantic HTML, which we wanted to provide. We use a lot of browser-based, like browser-provided APIs instead of building our own or using a CSS or JavaScript framework to build them for us. There's a neat bit of animation here and there, a bit of flourish, and schema.org works well for us as embedded metadata because search engines also, of course, use it and understand it. One thing we've learned, never hide navigation elements. It's always going to be an awful result. What's manageable in terms of testing all of this? Browser and mobile testing is easy to do. We've tested keyboard navigation, so all of this I can do on my own. I can also try to how well does everything get imported into Zotero if I use that web page. How well is it, like how easy is it to harvest the data? What's proven more challenging in this approach is there is a need for user observations and screen reader tests, and I need outside users for this to work well. Of course I can test my own, but I know how this is built, so I know what to look for. And this is something I still need to do. this is my conclusion or summary. The cultural heritage framework is designed to be useful for various types of cultural heritage data. Feel free to give it a whirl. Let me know if you have any issues with it. I'm happy for others to try using it as well. And yeah, I might be happy to hear from you. Feel free to let me know. That's it from me. See ya.